as we graph quadratics today, we're going to do the exact same thing, focus on those 4 key points, x-intercept, y-intercept, vertex. So as you work through this, if you need to refer back to what we had done last time, look at those notes. Okay, those notes have everything that we need in order to graph any form. That's all in there. So now we're going to add in and identify the domain of our graph or our function and the range of our graph or our function. First thing that I want to remind us about is how we state this. There's lots of ways of how you can talk about domain and range. We're going to use what's called interval notation. So the main kind of points here with interval notation is that we have basically 2 types of brackets. We have a squared bracket, and that squared bracket we use when including a value. Okay, and I'll kind of explain what I mean by that. Basically, it's if that value is actually part of the graph, if we can actually get to that specific value. And then we have a curve bracket when we do not include value. Okay, so like the regular parenthesis when we don't include the value, a good example of that is like infinity. A lot of domain and range is going to extend to infinity. And because we can't get to infinity, we're not really including that value in our domain and or our range. Okay, so squared bracket, that value is 100% part of the graph. Curve bracket, we get close to it or we're approaching that, but never 100% of the way get there. Now, the way that we write the interval notation, it kind of looks like regular parentheses, okay, like we got brackets, but it's going to be written in a way where we go the smallest value to our largest value, and I want us to make a note of that as well. So it goes smallest value to the largest value. And that's both the case for the domain and the range. Now, when we're talking about the domain, there are some questions you can ask yourself to easily identify that domain, right? Because x values, they move left or right. So for us to describe all the x values, we basically need to answer how far left and right does the graph go? Okay, how far left will tell us the smallest value, right? Because with x values, the further left you go, the smaller it's going to get. How far right it goes will tell you the largest value. You're going to see some patterns with our domain for all quadratic functions. It's the same for everyone. And then for the range, okay, the set of all y values, the question is basically the same, but now we want to think about it in terms of how y moves. Y moves up or down. Okay, so now our questions that we ask ourselves is how far down and up does graph go? Okay, so how far down is the smallest value? How far up it goes is the largest value. Again, those 2 questions should always lead you to describe what the domain and range is. Okay, another thing about quadratic graphs is they have symmetry, right? With that U shape, they're going to be symmetrical about the vertex. And so what ends up happening here is we get an axis of symmetry. It really doesn't have all that much value identifying an axis of symmetry, but it can be a way for us to get more points on a graph where we could get a point and reflect it across that axis of symmetry. So your axis of symmetry, the equation is x equals whatever the x coordinate of our vertex is. Okay, and we can do that or use that to add more points to our graph. So that way, instead of just getting 4 points, we could potentially get 5, okay, or maybe 6 or even 7. So it's just another way for us to add more points and make our graphs a little more accurate. Okay, so we're going to do 2 examples. And again, starting with the form and going through all these key features. And then we'll also talk about domain, range, and axis of symmetry. So also review from what we've been doing. So number 1, Again, if you don't look at that and identify as vertex form, you need to study that form sheet that I gave you all on Monday. So this is our vertex form. What's nice about vertex form is the vertex is easily identifiable, right? I can just look in my equation and say the horizontal shift is left 3, so -3. The vertical shift is down 7, so -7. Then for my x-intercepts, I'm going to let y equal 0. Do that over here. So I set the whole equation equal to 0, and I get 3 x plus 3 squared minus 7. So I'm like, okay, I have that squared term in here. I need to isolate that and then take square roots. So I'm going to add 7. So I get 7 equals 3 times x plus 3 squared. Then divide both sides by 3. So this is 7/3 equals x plus 3 squared. And this is where we'll take the square root. We are going to get a weird number. And again, we'll just convert it all to decimals. But the one thing I want to point out, and we talked about this on Monday, is that when we go to take square roots here, it's plus or minus. Okay, so let's figure out exactly what that decimal is. We'll round it, so we'll say like 3 decimal places. So square root of 7/3 is 1.53. And we're going to take plus or minus, and now it equals x plus 3. Now this is where I got a lot of questions yesterday, where a lot of you got to this point and you're like, okay, I'm not quite sure what to do with that. Well, the plus or minus 1.53 basically tells me we have 2 equations. One where we're going to use the positive 1.53 and one where I'm going to use the negative 1.53. So 1.53 is equal to x plus 3, and then negative 1.53 is equal to x plus 3. And so now, for me to get x by itself, I need to subtract 3 from both sides here. So 1.53 minus 3 gives me an x-intercept at negative 1.47. And then negative 1.53 minus 3 gives me negative 4.53. And those are our 2 x-intercepts. Okay, so negative 1.47 comma 0 and negative 4.53 comma 0. And I'll pause there for a second and open up for any questions with how I'm solving for those x-intercepts there. Okay, maybe a question about square root, why there's plus or minus, how I get the 2 answers. Okay. Then we'll move on to our y-intercept. And for the y-intercept, now I'm going to let x equal 0. Okay, so for the y-intercept, basically we're finding f of 0, which tells us to replace 0 or x in the equation with 0. So it's 0 plus 3 squared minus 7. Okay, you could, of course, just do everything in the calculator there. I'll even simplify some things before I jump into that calculator. Like I don't need that 0 plus 3. I know that is 3. Maybe from there I plug it all in and go that this is 3 times 3 squared, which I know that's 9, minus 7. I think it should be 20. Okay, and it gives me 20. So that's not going to fit on our graph. That is okay. So it's at 0, 20. And from here, this is where I would say let's go ahead and graph it. And then the 3 extra pieces, the domain, range, and axis of symmetry, it's going to be helpful if we can see that on our graph and to be able to identify those key parts. So now let's plot these points, and then we'll come back and identify domain, range, and axis of symmetry. So x-intercept of negative 1.47, that's in between negative 1 and negative 2. negative 4.53 in between negative 4 and negative 5. So 2, 3, 4, 5. And then the vertex at negative 3, negative 7. And then let's just kind of put that y-intercept. We'll call that 20. We'll extend this graph and we'll just say, hey, that's 20. Even though it's obviously not drawn to scale, it'd be way further up. And then let's connect our graph best that we can. It gets so steep there. Okay. So now, let's look at the axis of symmetry here. And again, the axis of symmetry is where this graph is symmetrical about. Okay, and visually, when we have that U shape, we can kind of see that it's right down the middle, or this vertex here. So we can fill that in. Okay, this is that axis of symmetry. Okay, abbreviated AOS. Okay, where every point on either side of this line is the same distance away. So even our x-intercepts, okay, the x-intercept to the right, it's approximately 1.5 away from that axis of symmetry. Same to the left, it's about 1.5. So where this can be useful is we have this y-intercept here over at 20. That y-intercept is 1, 2, 3 away from my axis of symmetry. Well, I can reflect that point across my axis of symmetry and thus get a better shaped graph. So I can take a point, go left 1, 2, 3 from that axis of symmetry, and take it up to the same y coordinate of that point that I'm reflecting. So this is also at 20. It's just that that point is at x equals, what is that, 1, 2, 3, negative 6. Okay, so you can use the axis of symmetry to reflect points and thus get the same points on either side and just make a better shaped graph there. And then every axis of symmetry has an equation. It's just x equals whatever the x coordinate is of our vertex. So our equation is x equals, well, every point on this line has an x coordinate of negative 3. Okay, so the axis of symmetry, not a ton of value. Again, it can help just to get a better shape of the graph, but in terms of solving any application or doing anything with it, doesn't make a big difference. Right, now for the domain. Domain, the set of all x values. Well, these arrows are really important, and not only are they pointing up, but they're also pointing out. So this left arrow is pointing all the way left to negative infinity. So the furthest this graph goes to is negative infinity. The furthest right that it goes to is positive infinity. So our domain, and the domain for every quadratic function, is negative infinity to positive infinity. And this is where the notation can be kind of confusing because that looks just like how we write all of our points, right? It looks like how I wrote my vertex or y-intercept or x-intercept. But those infinities should kind of give us a sign that, hey, that's more describing an interval. It's describing the interval of values from negative infinity to positive infinity, which is a fancy way of saying every x value is going to work here. Our graph is going to use every single x value. We're just getting a small glimpse of what that is. Now the range is different, and the range is going to depend on whether our graph opens up or down, right? The furthest down that this graph goes to is this vertex. That vertex is a minimum point. It does not go below that point. So the furthest down that this gets to is y equaling negative 7. So the smallest value or lowest is negative 7, and this is where I use that squared bracket, because that's part of the graph, right? I can point on my graph where y is negative 7. And then how far up it goes, these arrows are telling us that it's going to keep going up and up and up all the way to positive infinity. Okay. So mostly the same from what we've been working on past couple days, just adding in that domain, range, and axis of symmetry. Before I just let you all work through this assignment, why don't we all do number 2 just in our groups or on our on our own. I'll work it out as well. We'll check this one together, and then I'll let you all just work for the rest of the period. I can circle around and address any questions that you all have, figure out where we're having issues. It might be a good idea to get out the notes from Monday. Bless you. Ah, dang it. If you're stuck on something, let me know. You're gonna get time to do that. I need you to do this one right now. What are you pointing at? Okay. Yeah, do this one. You're going to get time to do those other ones. And if you're stuck on something, let me know. I don't think I paused the video. Nope. Okay, for everyone watching the video, sorry I meant to pause it. But you saw me do all my work for this particular problem here. The one kind of thing I'll point out is just how I reflected this y-intercept to the other side. It's just an estimate here for at least where the x-coordinate is. The y-coordinate is not going to stay the same. But again, I can just kind of reflect it so that it's the same horizontal distance away from the axis of symmetry, just to give me kind of that fifth point there and get this graph to be a little bit better shaped. After that, the domain, again, for every quadratic is negative to positive infinity. For the range, now our lowest value, it goes to negative infinity. It gets all the way up to a maximum point where the y value is 10.125. And that has a squared bracket because we can specifically get to that value at 10.125. And the last additional thing here is the axis of symmetry. That's at x equaling 1.75. Again, I get that just from the x coordinate on my vertex. Okay. Again, sorry for not pausing it a while ago. Yeah, have a great day.